I'm Rich van Arkel. I'm Associate Professor at Imperial, which is based in England, so you're going to have to excuse the double L's and the lack of Z's in my presentation. Everything's going to be spelled in English, so please forgive me if anything's lost in translation. It's a talk of two halves. My title is a pun. I want to highlight, I guess my starting standpoint is modelling is inherently credible, and it's used in a credible sense. And it's accepted that it's credible. So it's a growing part of modern medical device development. Knees, hips, even stents. You can use modelling as part of your regulatory submission. It's used in a very clever way. You model the size range of implants, you identify the worst case, and then you can do physical testing like fatigue tests on the worst case only. You verify and validate that they failed in the way your model predicts, and then you use the model for the rest of the size range. It's a really good use of resource. It's a really good use of money. It's a good use of time. It's very effective and it's acceptable. And these are just the ones that have become standards pretty much across implant development. Maybe I shouldn't talk too broadly when we've got industry here. But this is a technique that's being used more and more and more. And now it's out the bag. Now it is a thing. It's not going away. And you can just see that growing over the years to come. And so we also saw the V&V 40 guidelines. More and more papers. So it's interesting. I've actually got another two examples here, different to the ones you showed, where it's just showing those sorts of concepts of assessing risk and then judging how far you validate your models off that risk is penetrating the research domain as well. And we're seeing some really incredible work coming out. If I think as a slight step back broadly about where we use modeling, so this in device development, it's now well established. It is credible. And that's because it's based off validation. And it's used in a very intuitive way, underpinned, coupled with physical testing and using the modelling for distinct advantage. But I also think modelling is completely credible and very useful in discovery research, where you just can't do the experiment. It's too expensive or it's just not possible. I think it's a great use of modelling to say it's informed of physics. We can test a hypothesis. There's just no other way to test it. And in that sort of scenario, you can't really validate. But when I look at the papers where I really respect what's coming out, I think they do really great sensitivity analyses or uncertainty analyses. And it's really an inherent part of that modeling. And I still find that completely credible. And in the middle, which is where probably most of my research sits, would be in the insight and understanding. You're using the model to add value to something where data already exists. And there, depending on resource, depending on what your specific question is, validation or sensitivity can be highly appropriate to show that your work is credible. And if you look at some of the papers that are coming out, the standard is truly incredible and it's really, really exciting to see. But my title is a pun. And the other meaning of incredible is not believable. And I thought it's nice to just lean into the play on words, and I'll test whether modern modelling is becoming more incredible or more incredible. And the basis, I need a definition. And I think people who get validation or sensitivity or uncertainty analyses right, which pretty much everyone in the room does, you look at the rest of their paper and everything else you expect to see from good modelling is there. You can reproduce what they've done. They're often sharing their output, or if they're not sharing it, it's for good reason. And so they're great keywords where we can really search them and see how many people are using validation or sensitivity or certainty analyses in their modelling research. So I did this. I did a PubMed all field search over rolling 5-year periods from the very first knee model in 1976 up to 2025. And I did two searches, one just looking for modelling in knee, and one looking for those keywords of validation, validated, validity, something indicating it's done validation or sensitivity or uncertainty. And it's not pretty. So here we go. Validation and uncertainty analysis became a thing in 1986. And then it became increasingly popular. And we peaked at around 1 in 2 papers was trying to do some sort of validation or sensitivity analysis to justify their results. And then since then, it's getting worse and worse and worse and worse. And research is becoming more incredible. 3 and 4 papers in the last 5 years didn't have either a sensitivity analysis, an uncertainty analysis, or any form of validation. If we look at the number of papers published, this actually makes a really worrying stat that if we do the total sum of minimally credible papers, so this isn't saying they're good papers, this is just saying they had some sort of validation or sensitivity analysis. Since 1976 up to when I did the search before I got on the plane yesterday, there's almost as many nonsense papers published in the last 5 years alone. And so in the next 5 years, we're going to be publishing nonsense at a higher rate than the total existence of credible modelling research. And then I've actually saw a second trend within my trends. So if I just look at the use of sensitivity analyses, so this is for papers that had one or other, this is the ratio of sensitivity analyses compared to validation. This is also a downward trend. So we have the use of either validation or sensitivity analyses is trending down. And the sensitivity analysis are a downward trend within a downward trend. So if you like your Leonardo DiCaprio movies, you might think of that as downward trend inception. But I just can't understand why. If we take a step back and think, computing resource is more readily available than it's ever been. I actually looked at the spec of the PC I bought for PhD students in 2015 and compared it to the same price PhD student PC I bought this year. And they've got a 2 times increase in GPU performance, a 3 times increase in CPU performance. They got a solid state hard drive. They actually don't ever do their modeling on their own PC now. They just send it to the university supercomputer and they send them in a batch. All software is now optimized for multi-threading. I remember running Materialized Magic on a 32-core PC and waiting 24 hours because it was using one of 32 and my other 31 cores were just sat there not in use. But those days are over. Modeling, the software is better. There's open source start points. There's open source data for validation. And actually, my PhD students are hard done by. I haven't increased the amount I spend, but obviously the value of money has been eroded quite significantly in the last few years. And all of those are reasons why they have more PC power available than ever. And university, everyone has more PC power available. And a sensitivity analysis is like, you don't have to remesh. You've done your mesh conversion. You just change, you think of the number you're least sure about and you change it and click rerun. And I just can't understand why it is disappearing. So the minority are producing incredible work that's changing science, engineering, and healthcare. The majority are producing incredible work. We're at peak credibility. In the next 5 years, there will be more new incredible papers created than the total sum of all credible modeling since 1976. I think this is the crux why in 2025, we still have to question whether modeling is a credible research tool. I think at the top end it is, but I think there's a very large bottom end that is reputationally damaging for the field as a whole. And I think if we had to have a single message to push back on when you're doing peer review or when you're training people, when you're discussing, I think this lack of sensitivity or uncertainty analysis is a total missed opportunity in a world of readily available computers. Thank you.